Most of the laboratory courses in our chemical engineering curriculum are carried out in the 3-story unit operations laboratory, which is a special construction adjacent to the main building of the department. Pilot-scale systems for separation processes, process control and reaction engineering experiments are placed at the ground floor of the building. On the first floor, there are systems for fluid mechanics and heat transfer experiments. Experiment within the context of Chemical Engineering Laboratory 1 course, which provide the students to practice their knowledge acquired in fluid mechanics course are flow pipes in hydraulic networks, laminar turbulent flow, airflow, mixing of liquids, and fluidization. These systems mainly include pipes, elbows, valves, manometers for the measurement of pressure difference, sudden expansion and sudden contraction zones, venturometers, orifice meters, and pumps. Using the data obtained from these systems, the quantities related to fluid behavior and transport, such as pressure drop, friction loss, and flow velocity, can be calculated. Experiment within the scope of the Chemical Engineering Laboratory 1 course that provide the students to practice the knowledge in heat transfer are heat transfer by conduction, cross-flow heat exchanger, double pipe heat exchanger, natural and forced convection, and fluidized bed heat transfer. These experimental systems mainly include an electrical energy source, pipes where heat transfer takes place between fluids, thermocouples where temperature values are measured, thermometers, indicators, and blowers that provide fluid flow. With the data obtained in these systems, quantities such as the amount of heat a fluid gained or lost, individual heat transfer coefficients, and total heat transfer coefficient can be calculated. Chemical Engineering Laboratory 3 experiments, namely packed bed distillation, stage distillation, absorption, level control, solid liquid extraction, dryers, atomizer, solid separation, and cyclone separation give the chance to practice the knowledge acquired in the mass transfer, separation processes, and process control courses. These systems are pilot scale and include units such as columns, boilers, thermocouples, controllers, and control equipment. The data obtained in these experimental systems help to find the height of separation columns, number of stages, product concentrations, drying rates, moisture of solids, and efficiency of systems. A short information about each experimental system is given in the Introduction to Experimentation videos, whereas the detailed information including the experimental procedures for each system in the Unit Operations Laboratory can be found in the department's laboratory manual.